Okay, so we're just going to talk about the properties of exponents and radicals. We should have seen these in Algebra 1, but we'll review them here. So the properties of exponents apply not only to integer exponents, but also rational exponents, which that is what our topic is about in topic 5. So let's let m and n represent rational numbers, and a and b cannot equal 0. Because if our bases are 0, then these properties don't work. So we have the product of powers. Okay, our first one is the product of powers. And this is when we have a to the m power times a to the n power. Okay, so the bases are the same and the exponents are different. And what we do when we're multiplying these, we're taking the same bases with different exponents, multiplying them. We add the exponents, okay? So we add them here. So an example of this would be, let's say we had 2 to the third times 2 to the second. Sorry, my 2's not so good there. That would equal 2, the base stays the same, to the 3 plus 2 power, or 2 to the fifth, which of course we keep seeing that would be 32. All right, so the quotient of powers, okay, this is when we're dividing them. So when we multiplied them, we added them. When we divide them, we're going to subtract them. So if I have some a to the m power divided by a to the n power, I'm going to write that as a to the m minus n. So just this is going to be subtraction instead of addition, opposite, okay? So for example, if I had 2 to the fifth power over 2 to the third power, I take the base 2 and I subtract the exponents, numerator minus denominator, and I get 2 squared, or 4. Okay, so that's the product of powers and quotient of powers. Let's go ahead now and look at, I'm going to erase this stuff so that we can, let's see, clear screen. There we go. All right, so let's go ahead and now start with the power of a power. So this is when I have a base raised to a power, and then that is raised to another power. So we have a to the m raised to the m power. So when we have a power to a power, we're going to multiply those exponents, okay? So a to the m times n. So this will be like when we have 2 to the third power raised to the second power. This means it's going to be 2 to the 3 times 2, which is equal to 2 to the sixth power, which is going to be 64. Okay? 2 to the fifth power is 32. You multiply that one more time by 2 and you get 64. All right. And then we have the power of product. Okay. The power of product. This is just when you have some variables or constants inside parentheses all raised to the same power. Okay. So here we have a times b in parentheses raised to the m power. This just basically means you distribute that exponent to both of those variables. So we get a to the m, b to the m. So let's say we had 2a raised to the fourth power. This means that the fourth power applies to both things inside the parentheses. So we get 2 to the fourth power, a to the fourth power, which is going to equal 16a to the fourth power. Because 2 to the fourth power, remember, is 2 times 2 times 2 times 2, or 16. All right, and the last one is this negative exponent. Of course, this is always the one that I think is pretty difficult for most students. So if we have a to the negative m, so some base raised to the negative power, we're going to flip it kind of. So a to the negative m right now is really in the numerator, and we're going to just flip it and put it in the denominator and make it positive. Okay, so let's say we had 2 to the negative fifth power. Okay, and remember, this is really like there's an invisible 1 down here. We're going to take the reciprocal or flip it, move it to the bottom floor. When it moves to that bottom floor, it becomes positive. So we get 1 over 2 fifths, 2 to the fifth power, sorry. And as we've seen many times now, 2 to the fifth power is 32. All right, we have finished the properties of rational exponents. Woohoo!